This is Abstract Your Code and Other Bad Advice That I Learned in School. My name is Daniel Shumway. You can find me online at danielshumway.com or on Twitter at danielshumway. I'm working on a game called Reset Hard. It's a time-traveling puzzle game about learning to do impossible things. It also has co-op and competitive multiplayer, and I am building the engine and all of the networking code and everything myself. Before I was doing that, I was at Oracle for about 3 years doing fairly low-level web framework programming. And before that, I was at RIT studying game design and development. So there's this advice that you get sometimes in financial circles when you're talking about money management, that you need to spend money to save money sometimes. And that's technically true, but it's the type of advice that's become sort of so generally accepted that it's no longer particularly valuable or good advice to give people. And similarly, if you are in formal education, or even if you're just learning to program off of Stack Overflow, there's a lot of advice that you're going to get that used to be really insightful and that used to be really valuable, but has become so generally accepted that it's no longer that great to know. Stuff like, don't ever use global variables. Break apart large functions. You should never have a function that's more than 100 lines. Never, ever, ever use a public variable. You should use getters and setters for absolutely everything. And prefer high-level abstractions whenever possible. And if you ask people, well, why should I actually abstract my code? They'll say, well, it allows you to hide messy details, which means you can look at the general overview of your code rather than the specific details. It forces your code to be consistent across the entire code base, which means that your code will be predictable and it'll be easy to get people up to speed on it. It forces you to think about your APIs and your paradigms before you start coding rather than after. And it separates your intent from your implementation. And when you're coding, usually you want to know what's intended to happen, not what actually happens. And all of this is technically true, but abstractions also come with some significant downsides. For example, they hide messy details, which means it's harder to get at those details later when you find bugs in your code. They also force your code to be consistent across the entire code base, which means that you're going to spend a lot of time trying to fit square pegs into round holes. And you're going to spend a lot of time trying to retrofit solutions to fit your existing paradigms rather than just coming up with the best solution. It also forces you to solidify your API and to think a lot about the paradigms you're going to use before you start programming. And usually when you start programming a complicated product, you're not in a position to know what your API is going to be. And finally, it separates intent from implementation. And it turns out that in the real world, implementation often matters a lot more than intent. So here's a relatively controversial idea, I guess. Abstractions don't actually make code simpler. And I want to break down exactly what I mean by that. When you abstract code, you start with an implementation. You start with the code that actually does the stuff you're trying to do. And then you sort of build this kind of boilerplate style stuff around it so that it's easier to invoke that code or to work with it. But the thing is that when you add that abstraction on top, the implementation doesn't go away. And if you're a 1 or 2 person team working on a complicated project like a game engine, you don't get to forget about those implementation details. They're still there. You still have to maintain them. You still have to think about them. They're just extra information. And when you think about it this way, 100% of the time, literally 100% of the time, anytime you add an abstraction to your own code base, your code becomes more complicated if you are looking at the project as a whole. And I suspect that phrased this way, even people that advocate for abstractions would actually kind of agree with me. So given that, why would we abstract anything? Like, let's put ourselves in that position. Why would we still abstract things? And if you ask someone, I think what they'd settle on is that sometimes you have to make things more complicated to make them simpler. sometimes you have to have a complicated framework so that in the future your code will be simpler to write. Sometimes you have to have a complicated API so that in the future you'll be able to deal with simpler concepts. Sometimes you have to spend money to save money. And all of these things are technically true. Sometimes this is true. But at the same time, it's kind of nonsense, right? Because when you think about it, the best way to save money is to save money. It's to spend less. The best way to reduce complexity in your code is to do fewer complicated things. All of the stuff that I'm talking about, all of the stuff that I'm bringing up, it's not normal. All of these rules are the exception. They're not the general case that you're going to run into most of the time. Why do we do this? So why do we take these general case scenarios? Why do we take these general, obvious things, in order to make things simpler, you should make them simpler? And why do we throw those away and then treat the exceptions as if they are the rule? And I think the answer is because it feels really good to do that. It feels good to go to a store and spend a lot of money and say, well, when you think about it, actually, I'm being more efficient because this product will last longer. It feels good to say that. And it feels good to abstract code and to come up with these APIs and complicated structures on top of things. It feels good to be clever. It feels a lot better to be clever than it does to be sensible or normal. So I don't have a ton of time left, but in conclusion, if you're learning how to program, there's a lot of advice that you're going to be given, both in formal settings and in informal settings, that basically boil down to, here's a best practice, follow this best practice, this is what you should always be doing. And in reality, there are no best practices in software development. There are patterns that you can use that have effects on your code. And it's really up to you to figure out when those effects are applicable, what the downsides to those effects are, and to sort of apply a set of common sense on top of everything to say, what is actually the best thing for me to do for my code in this situation? Thank you very much, and that's the whole thing.